Hi everyone, welcome back to the coding series. Today's problem is search insert position. Let's understand the problem statement. Given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. Let's understand this. Here target is 5 and given nums. Okay, here target is present in given nums. Okay, if it is present, you have to return its index. So the output is 2. In the second example, target is 2, but 2 is not present in nums. If 2 is not present, then you have to check where this 2 can fit in the array. Okay. Here, since the array is sorted, 2 should be fit in between 1 and 3. Okay. Then, after that, you have to return the 2's index. Since 1, 2, 3, 5, 6, so 2's index will be 1. Okay. Now, target is 5. Target is 7, sorry. Here, now you have to check. Here 7 is not present in nums. Now you have to check where this 7 can go. Okay, here 7 goes, since this is sorted array, after 6 only 7 comes, right? So you have to put at the end of the array. Okay, so the output is 4. Now let's see how we can solve this. So given nums 1, 2, 3, sorry, you can take 1, 3, 5, 6 only. 1, 3, 5 and 6, and target is 2. Okay, now let's start with root. Okay, iterate over an elements, iterate over an array I less than n. N means length of an array, I plus plus. Okay, now first check will be whether our current element is equal to target or not. If it is, then you can just return I, because I will be the position of a target, right? So you can just return I. Now we'll see what other steps can be. Okay, here now when we are traversing through an array, when I equal to 0, nums of I will be 1 because the first element is 1. Here 1 is not equal to target and 1 is less than target. Okay, if 1 is less than target, since the array is sorted, we are not sure, like you have to iterate the, and you have to go and check the other elements also, because 2 can be present, cannot be present, that we are not sure. So for that you have to check. Okay, now I equal to 1. Okay, here nums of I is 3. 3 is greater than target. If 3 is greater than target, then the elements, like the current element is 3. Okay, if current element is greater than target, then the elements to the right side of that will be also greater. Okay, so it's of no use traversing and checking other elements. Okay, if you put, then we are like we can fit 2 at this position, right? So you can just return I. Okay, now we will else if nums of I is greater than target, then you can just return I. Okay, else you have to traverse. Okay, because here I clearly mentioned why we have to traverse. Okay, here time complexity will be O of n. Let's take target. I will tell you why. Let's take target. If target is 7, we have to iterate till last, like you have to iterate whole array. You have to traverse whole array. Okay, and then you will get to know where you have to put our target, right? So here, if you take here, I will explain. Here nums of when I equal to 0, 1 is not less than 1 is not equal to 7, but 1 is less than 7, you have to traverse. Then 3 is less than 7, you have to traverse. Okay, here 5 5 is less than 7, you have to traverse. 6 is less than 7, you have to traverse. Then, okay, you will reach end of an array. Then we are sure that you have to put at the last, sorry, this will be I. This will be I. Because after this, I will be, after the end of the iteration, here I will be 0, 1, 2, 3. At 3 position, it will go inside. Next, I will be 4. But 4 is less than, here n is also 4, so 4 is not less than 4, right? So you can, then 4 is pointing to the, so 4 will be pointing at the end of the array, so you can just return I. So here, to check the target, and okay, if it is present, you can just return. Then also you have to check, like, till the, you have to traverse the whole array, right? So if if our array is containing n elements, then time complexity will be O of n and space complexity will be O of 1, because we are taking one extra variable. Okay. Now here, time complexity is O of n and space complexity is O of 1. But this is not the optimal way. Okay. Here they have mentioned that you have to write an algorithm with O of log n time complexity. Okay. Now let's see. Here binary search comes into picture. Okay, when we can apply binary search? Okay, in the last video I have mentioned that when we can apply binary search, if array is sorted, if array is sorted, then you can apply binary search. Okay, and I have clearly mentioned how binary search works and all. Okay, how you can check whether this element is present in the given array using binary search if that array is sorted. Okay, now let's take the same approach. Here 1, 3, 5, 6. Let's write same code. Here low will be pointing to, you can check it to the previous video. I will add that link in the description. I will add the explanation link. So low will be pointing initially to the first index, high will be pointing to the second index, last index means that will be 3. Okay, now for low less than high, now you have to calculate mid. Mid will be low plus high by 2. Okay, now if, now you have to check whether that mid is equal to target or not. If it is, then you can just return I, sorry, mid, because mid will be pointing to the target's index only. Else, if nums of mid is, if our mid is less than target, okay, then low will be mid plus 1. Else, whether it will, nums of mid will be great, whether it will be equal or less, then it, if not, in the else it will be greater only. So if it is greater, then high is equals to mid minus 1. As I mentioned in the last video, I have clearly mentioned why I have added this, like why I equated this low equal to mid plus 1, high equal to mid minus 1. You can go through that video and come back to this, and then you can see. Okay, now let's see. Okay, now let's see here. Since low will be 0, okay, and high is equals to, still you have to do some modifications here. I'll explain. Okay, high is equals to 1. Sorry, high is equals to n minus 1 means 3. Okay, now mid will be 3 by 2, that will be 1. So mid will be pointing to here. Okay, so now here it will check 1 and take target as 2. Okay, So 1 is not equal to 2. Okay, so it will not come here, it will check this one. But sorry, here nums of mid, sorry, that is 3, right? Because nums of mid is 3. So here 3, now it will check 3 is less than 2. No, 3 is greater than 2. Okay, 3 is greater than 2 means high is equals to mid minus 1. Mid minus 1 means 0. Now low is equals to 0 and high is also 0. Now this one, okay, and mid will be also 0. 0 plus 0 by 2, that will be also 0. Now it will check whether this is equal. No, because nums of mid is 1, that is not equal to 2, but 1 is less than 2, right? 1 is less than 2. Now low goes to mid plus 1, that is this one. What is that? 1 plus, here mid is 0, so low will be 1. Okay, now low is 1, high is equals to 0. Okay, here low less than or equal to, okay, low less than or equal to, so here 1 is not less than 0, right? So you have to, you will stop going inside for loop. Then now you have to check. Okay, here low is 1, mid is pointing to 0, mid is pointing to the first element. Okay, now you have to, we are sure that mid will be, because target is 2. Okay, now you have to check if nums of, like, you have to check whether nums of mid, if nums of mid is less than target, okay, then we are sure that it will be just beside to that only. Okay, then it will be, you have to return mid plus 1. Okay, else, okay, suppose if our target is 0, okay, if our target is 0, then same, you will come till here. Okay, you will come, not here, just here only, I guess. Let me see here 3. Here nums of 1. We'll see. We'll see that also. Here, what if our target is 0? Okay, 1, 3, 5, 6. Now, in same, mid is equals to 1. That means 3 is not equal to 0. But 3 is greater than 0. 3 is greater than 0 means high equal to mid minus 1. Yeah, as I told, it is will be same, high equal to 0. Now, low is pointing to 0. High is also pointing to 0. Mid will be also pointing to 0. Okay, same. Here 1 is not equal to, 1 is not equal to 2, right? 1 is not equal to 0. 1 is not equal to 0, but 1 is greater than 0 here. So same again. Okay, high equal to mid minus 1. High equal to mid minus 1 means high will be pointing to minus 1. Okay, now here low is 0, high is minus 1. So you won't be going inside of our loop. Now here mid is 0. Okay, then we are sure that you have to put our given target at first index only. Okay, that's why you have to return mid. Okay, I will explain you this one. Okay, if our target is 7, if our target is 7, if you see same, okay, let's take 1 3 5 6 only. Okay, you will reach, I will explain you that 1 3 5 6. Okay, low will be 0, that means nums of mid starting will be 1. 3 is less than 7, yes, 3 is less than 7, then you have to, low will be mid plus 1, so that will be here, because mid will be pointing to here in the initially, because mid will be 1. Okay, when you calculate, because low will be pointing to 0, high will be pointing here, so if you calculate, then mid will be 1. Now after this, low will equal to mid plus 1, then low will be pointing here. That means now you, if you calculate mid, this is 0 1 0 1 2, 2 plus 3 by 2, that is 2. Okay, that means here same 5 is less than 7. Okay, then again you have to increment mid. That means now mid will go 2 plus 1 3. 3 is less than or equal to 3. Okay, here mid is 3. Okay, again here nums of mid, that is 6. 6 is less than 7. Okay, now again you will increment low equal to 4, but 4 is not less than 3, so you will stop the iteration. Okay, you will stop the iteration and you have to come out of that. Now if you see, now you don't know where you have to put our target, right? Now you have to check this whether nums of mid is less than or greater. Okay, if our nums of mid, here nums of mid is 6. Okay, because mid is 3, so 6 is less than target. So then we are sure that we have checked all elements, since the last element, like the mid element, is also 6. Okay, but and it is less than target. Okay, since our mid is less than target. Okay, then we are sure that you have to put after this only. That's why return mid plus 1. Return mid. Here we are using binary search, so time complexity will be O of log n and space complexity is O of 1. Okay, now let's see. Let's code this. Okay, so low will be equal to 0, high is equal to len of nums minus 1, and mid initially let's take, okay, mid is equals to 0 for low less than high, less than or equal to high, calculate mid. Okay, that will be low plus high by 2 if nums of mid equal to target, then return mid. Okay, else if nums of mid is less than target, then high equal to mid minus. If our nums of mid is less than target, if our nums of mid, if our nums of mid is below the target, then low is equals to mid plus 1. Sorry, low is equals to mid plus 1, else high is equals to mid minus 1. Then you have to check if nums of mid is less than target or not. If it is, then you have to return mid plus 1, else return mid minus 1. Let's submit. Yeah, let's submit. Sorry, this should be mid. Here I mentioned, right? This is mid. Yeah, that should be mid. Let's submit one more time. All test cases are passed. That's all for today's, guys. If you have any questions, please do add in the comment section. Like and subscribe for more videos. Thank you.